Hello, grade 9. Good afternoon. Welcome to this revision lesson. We are still revising mechanical systems and control. Today, we are doing under mechanical systems and control. We'll look again at the ratchet and pawl. Then we'll look at brakes today. We'll look at disc brakes and also the bicycle brake. It's not much that you are going to do, but I hope that you will understand and also look at all the other work under mechanical systems and control that you have done so far, because this is the last aspects that were left under mechanical systems and control. Okay, look carefully at the questions and answers. Okay, even as you speak. If there is some clarity that you need, please do ask. Now, today, I said we are going to look at brakes. You know, all along we've been looking at systems and how they operate. We looked at systems diagrams, okay? Can somebody please remind me, what are the components of a systems diagram? When we are talking about a systems diagram, what are the main aspects of a systems diagram? How do you draw up a systems diagram? Main aspects of a systems diagram, anyone? We have done a lot of systems. And I said for every system, we must know the systems diagram. Grade 9, are you there? Onkabeti, yes. In mechanical systems, we look at systems, and when we understand the system, when we are happy that we now know the system, then we draw up a systems diagram. So, what are the main aspects of a systems diagram? Anyone? What are the main aspects? Let me see, how many are we here? 7. What are the main aspects of a systems diagram? Yes, what makes up a systems diagram? If I can give you a pencil and I say draw the systems diagram, you are going to draw 3 boxes. What will be the headings of those boxes? What will be the headings of your systems diagram? Where's my grade 9? Remember, in any system, we want to see the input. The input, Then the second block will have the process. Then the last block will have the output. And those will be joined by arrows. Angit, have you forgotten? Input, process, output. Yes, yes. So let us look at this bicycle. Okay, what is the input for this bicycle? What is the input? Pedaling. Yes, Tando, good. Pedaling will be the input, okay? There's the foot, the arrow on the pedal. So, and then what will be the process? The process? What will be the process? The chain, yes, the rotary motion of the driver wheel, okay? Rotary motion causes rotary motion of the wheels. The pedal, it moves the gear, and then you have the wheel following that in a rotary motion. Then the output, what is the output? The output is the output another rotary motion. The output is a moving bicycle, but the output will be linear movement, rotary movement changed to linear movement of the bicycle. So that is the output, the linear movement. The process is the rotary motion. The output is the linear motion, okay? So while the linear motion is taking place, this girl here may need to stop her bicycle. That is when she will apply the brakes. Okay, so the brakes is a control mechanism. Okay, the brakes are one of the control mechanisms. So when she applies the brakes, these are the brakes. We'll be looking at these brakes. The application of the brakes will stop from turning. Right, a brake system prevents movement completely because we said the output is a linear movement. So to stop that linear movement, we must apply brakes. It does not allow movement in any direction. To be safe, when you ride a bicycle, you need to control the speed. You need brakes. One type of a bicycle brake is shown on the right. So the brakes are a control mechanism. Okay. Brakes are a control mechanism. Now, these brakes, we call them caliper brakes. Now, let us study them. To understand how the caliper brakes are made, you would have to understand maybe these illustrations. You imagine a pair of scissors, okay? If you look at this pair of scissors, if you just know how the caliper brakes are made, imagine if this end of the scissors was bent to be like this. This is actually called a caliper, this, okay? So if this is moved, these handles are moved together, okay, then they operate the caliper section. That is how the caliper brakes of the bicycle operate, okay? When this closes, then what will happen? This caliper part of the brakes will hold the wheel like this, okay? The system, this is the system of the brakes of bicycle. It is better illustrated here when it is compared to the calipers. So that is why it is called a caliper braking system. If you can look at, this be made of steel, but you have some pads, you have some padding here. So these pads is what will hold the wheel. You can see the pads here. So these are actually brake pads. So the calipers, they do have brake pads as well. Okay, I'm sure you have heard your parents saying they are going to change brake pads of their car, together this braking system. So one has to ensure that all these fittings, they are tied together. Those screws are neatly tied together for the braking system to operate efficiently. Okay. Now, because you understood the braking system of a bicycle, let us look at the brakes, the disc brakes of a car. Now, this part that you are seeing here is actually attached to the wheel of a car. Okay, if you have to attach the wheel, it will come to these four fittings here. The caliper works in a different way to a bicycle brake. It exerts a squeezing force. The caliper of the car, this car, of these brakes of the car. It exerts a squeezing force on a disc behind the car wheel. Now, if you look at the brakes, they hold the wheel itself. Car brakes don't hold the wheel. The pads, the brake pads, they're attached to the wheel. That's how the bicycle stops when you apply your brakes. But here, this caliper works in a different way to a bicycle brake. It exerts a squeezing force on a disc behind the car wheel. So that is how these brakes are a control mechanism in a car. These are disc brakes of a motorcycle. Okay. they have a different holding to that of a car because they are attached to the wheel itself. Okay. When you look at this one, it is different. The wheel has been taken out. This is behind the car wheel. This one, it exerts a force on the wheel itself. But with the car, it is different. The brakes are applied on something that is behind the wheel. So after this, the wheel will be attached and it will be fastened to this. There will be bolts here fastened to attach the wheel. Now, this one is different. That of a motorcycle. It acts on the wheel. It is attached to the wheel itself. Now let us look at the parts of a disc brake. A disc brake system consists of a brake disc, a caliper, and brake pads. This is the brake disc. When the car is stopping and it's making a screeching sound, it means that the braking system is compromised. The brake pads must be changed. Okay, so what you are seeing here, where we attach the wheel, it is this part, okay? So it is here where you attach the wheel. And then you have your caliper, this caliper, okay? You'll notice that it looks more like this caliper, okay? Here it is. Now, this is a brake disc, okay? And then you have your output piston. You have your brake pads here. That's why if you don't have brake pads, if your brake pads are worn out, the car will make a screeching sound because the brake pads have a rubber surface. Now, if the rubber is worn out, the screeching sound will come from the friction of the caliper and the brake disc. Okay, so it becomes very important to change the brake pads from time to time because if there is friction between the caliper and the brake disc, you might end up having to change not the brake pads, but also the discs themselves. So if a car has not been serviced properly, you know, like changing the brake pads on time, you will see that there are lines, friction lines on the brake disc that show that the brake disc was now interacting with the caliper and the brake disc will be worn out. So to protect the metal and also the safety, just safe operation of the car, the brake pads have to be replaced at all times. And then you have your hydraulic oil. We did the hydraulic systems with you. You have seen how a hydraulic system operates. So when you apply your brakes, okay, there is a flow of this hydraulic oil. The hydraulic oil, it goes to the output piston. Okay, so when you apply brakes, you exert a force that will drive the hydraulic oil through to this output piston. Remember when you did hydraulics, you saw the input piston and the output piston. In the case of these brakes, the output piston is here, and the ram of the output piston will be the brake pad. So it will be attached. That force will be will exert on the output piston for the brake pad to come and touch on the brake disc on both sides, and then the car will stop. Okay, that is how this brake system of a car works. Any questions? Questions? Are you still here? Why are you so quiet? Grade 9? Okay, please tell me, what would happen if there was a leak somewhere of the hydraulic oil? Who can tell me? What would happen if there was a leak in this system? We discussed it when we did hydraulic systems. The car won't be able to brake, okay? What would be the cause for the car not to? I wish you could talk to me. Oh, okay, but you can type, it's fine. I want to know how you think the output cylinder here would react. What would be the reaction of the output cylinder if there was a leak of the hydraulic oil in the system? Yes, the car won't be able to stop, but I want your answer to show me that you understand the operation of the hydraulic system within the car brakes. Okay, let me explain to you. What you don't see in this picture is the brake pedal inside the car. I'm driving the car and I am applying my foot on the brake pedal. I just know when you out of fluid, it's a problem. Okay, my child. Now, when you apply brake, you apply your brake pedals. You put pressure on your brake pedals inside the car. You're driving the car. Actually, what happens is that that becomes the input. It becomes the input. The input is on the brake pedal. Okay? So the process is that the hydraulic fluid will move, there will be a flow of the hydraulic fluid, okay, through the system to the output piston. Okay, now that hydraulic fluid will be carrying the force. Remember Pascal's principle. That force will come to the output cylinder and it will be multiplied. And then that force that is multiplied will exert on the output cylinder and push the output cylinder so that the brake pad will come to the brake disc. And then that attachment will prevent the wheel from turning. Then the car stops. That is the operation. So the input is on the brake pedal inside the car. And the process is the flow of the hydraulic fluid, okay, to the output cylinder. And then the output cylinder will be moved. It will be multiplied on the output cylinder, and then it will move the output cylinder so that the ram of the output cylinder, which is what? Which is the brake pads, will touch the brake discs and the car will stop. Okay, is it clear? So this diagram doesn't have the input. It only has the output part of the system. But for you to understand the system completely, you have to understand that it starts from the brake disc, from the brake pedal. That is where the input is, from the brake pedal, when the driver is applying the brakes. Okay. Are you happy about are you happy about the brakes? Okay. Now, this is how a car disc brake operates. It is a control mechanism. Other control mechanisms are the cleat and the Ratchet and Pawl. Now, the cleat is the second time now that I bring this control mechanism. Okay, I wanted you to see it in context of the brakes. That's why I brought in the brakes in today, together with this, the cleat and the Ratchet and Pawl. Right. A valve system like that in a hydraulic car jack only prevents movement in one direction, but allows the movement in the opposite direction. I don't know how I made these O's. I'm sorry about this. Right. So a cleat is like a valve. It allows movement in one direction, but not in the opposite direction. Do you remember when we did the hydraulic brake system, the hydraulic jack system? Okay, when you press on the plunger, or when you, not the plunger, but when you press on the lever, when you press on the lever of the car jack, you apply force to the input cylinder. Then the input cylinder is pushed down. Do you remember? The input cylinder is pushed down, and then that causes the valves to open. And then when the valves open, the hydraulic fluid will start flowing. The hydraulic fluid flows to the output cylinder. Now, the valves allow one-way movement of the hydraulic fluid. That the valves in that hydraulic system are a control mechanism. Okay? They are a control mechanism for the hydraulic fluid in the system. But now, other control mechanisms that work exactly like the valves are the cleat, and the ratchet and pawl. Why? The cleat allows one-way movement. The cleat allows movement in one direction. When you try to operate a movement that is going to the opposite direction, the cleat will lock it. It will not allow it. So here are the cleats here. This is a cleat system. So you have these teeth which are going to hold this rope and allow it to flow only in one direction. Just like in the cable ties. Do you know the cable ties? Do you know cable ties? How do the cable ties allow one-way movement? Who knows cable ties? Do you know those plastic strings that we use to fasten something? Cable ties, you know the cable ties. We use them to fasten things, okay? So how do the cable ties allow one-way movement? Have you seen how the cable ties allow one-way movement? The movement of the cable ties only goes to the direction of tying. If you try to untie, there are teeth which do not allow you to untie. So those teeth, they act like a cleat, okay? They act like a cleat, right? They allow one-way movement. So it's one example also of a control mechanism, the cable ties. So this is like the cable ties. They allow you to slide this rope in one direction. When you try to slide it in the opposite direction, then they close. A cleat is like a valve. It allows movement in one direction, but not in the opposite direction. Okay, the device on the right below is called a ratchet and pawl. Okay, so this is the ratchet and this is the pawl. Okay, the wheel with the teeth is the ratchet and the other object is the pawl. So you can, with the ratchet and pawl, you can have this movement to the direction of the arrow. If you try to have a movement in the opposite direction, the pawl will stop the movement. So this is also another control mechanism. I think now you can give me examples of control mechanisms that you know, okay? Right. Now, let us look at cleats. This is one cleat. It is made from rope and some metal piece. Right. Explain what a cleat looks like and give the function of a cleat using the picture below. Okay, a cleat is made of metal or plastic and has two horns extending parallel to the deck, these two horns. It is used for attaching a rope to, especially on boats and canoes. Okay, so this is a cleat also. Okay, types of cleats. There are three main types of cleats. Okay, I have made this table for you, but this table can appear in your assessment. Okay, look at the illustrations of cleats. We have a cleat. This is a cleat. Description of the cleat, it uses two cams to clamp the line in between them. Okay, do you remember the camshaft I discussed with you yesterday? operation of the cam. So this is a cam cleat. Okay, it has 2 cams. And we have a jam cleat. The jam cleat holds a line without letting it slip. Okay, the jam cleat. It has 2 jaws with teeth. Here, it has 2 jaws with teeth. The line is placed between the 2 jaws. You can see there is a line there. It is placed within 2 jaws. Okay, this is a jam cleat. Then we have a clam cleat. Right, the clam cleat has 2 halves which look very similar to the halves of a clam. The rope is placed between the 2 fluted pieces. The rope will go in here. So this is a clam cleat. Okay, Unkabets. Okay, we'll upload them to the drive. Okay. These are types of cleats, right? So I will let this stand for 2 minutes so that you can take a good look at it. Right, types of cleats: the jam cleat, the cam cleat, and the clam cleat. All right, you must be able to identify them and describe them. Okay, then the ratchet and pawl. Where do we find the ratchet and pawl? The ratchet and pawl can be found, for example, in a car seat belt. The ratchet and pawl here, you can see here is the ratchet, here is the pawl. Okay, so this is the pendulum. The pendulum is what rotates. Okay, it's what turns. Okay, now let us look at the ratchet and pawl. You know, when you fasten your seat belt, you fasten it and it keeps you in that position. Okay, it doesn't, it only rolls when you pull it, but once you fasten it, it sits still in that position. It is because this ratchet and pawl have interlocked to prevent further moving of this seatbelt material. So that is how the ratchet and pawl of the car operates. Because if it doesn't operate like this, what could happen? Okay. What could happen if this, the car seat belt didn't have a ratchet and pawl system? What is the function of the seat belt? What is the function